Welcome to today's Fine Homebuilding webinar, the great debate, Parallam PSL versus Microllam LVL. For headers, beams, posts, and girders. This is sponsored by Weyerhaeuser Truss Joist. I'm Fine Homebuilding contributing editor Ian Schwant. Today I am joined by Weyerhaeuser Truss Joist territory manager Steve Radowski. Steve will be presenting on the differences between LVLs and PSLs, when to specify one over the other, treated and untreated options that are available specifically in the PSL, and tips and tools for accurately sizing to ensure structural integrity and code compliance. And with that, I will turn it over to Steve.
All right. Well, thank you, Ian. I appreciate the time tonight. I appreciate everyone that's logging in. Looks like we've got quite a following again. So like Ian said tonight, I mean, questions and answers, that's what everything's about. It's about a learning experience. We don't want this to be just me talking. Obviously, any questions that you have, Ian, I told him interrupt me. Some of them we might wait till the end, and some of them might actually get answered as we move through the slide. So with that, again, my name is Stephen Radowski. I'm a Truss Joist territory manager based out of the Philadelphia, Pennsylvania area. If you want to put in the chat kind of where everybody else is from would be great. And we'll get moving on. Whoop. That's not what I wanted. So before we begin and really get into it, I want to do a quick little exercise in critical thinking. So in the question and answer box, I'd love to see what everybody thinks about the next slide. I'd love to know who comes up with the right answer. And I actually gave this in an AIA session today as to get everybody kind of moving and engaged, and actually gave the explanation of the history of why one works better than the other. But moving on, that was just to keep everybody interested.
Getting a lot of overs.
So I guess since we have a lot of overs, we'll just go with, from a sanitary standpoint, over is the better way of doing it. If wind was to blow, the paper cannot actually really touch the wall when it's just draped down one or two sheets. So for those of you that would like to Google that or check it out and tell me some other information, I'd love to hear it. But the second thing I want to do, this is about how's your memory. So I'm going to flash 3 numbers across the screen, and they will become relevant at the end of this presentation. They're going to go once and then twice. And those numbers that were there, again, just something fun to kind of keep everybody interested as to what's to come towards the end. And with that, let's kind of roll into this great debate. I know that pretty much throughout the lower 48 US and into Canada, everybody likes to discuss what's your beam of choice. And tonight we're really going to be discussing engineered lumber and what Microllam, as a registered trademark to Truss Joist and Weyerhaeuser, is known as more or less the Kleenex of the tissue market. So we are what LVL is, same as Parallam or PSL. And really I want to talk about what's good, what's bad, and what's the cost difference between using the two, and would really love to hear from people in the audience as to their experiences and really what their feeling is about the conversation tonight. So just a quick chart, I'll leave it up for a couple of minutes. These are a couple of the topics, or most of the topics that we're going to touch on tonight, where PSL and LVL line up against one another, their strong points as well as their weaknesses. And we talk about weaknesses, not necessarily in a structural standpoint, but maybe in the installation and application of how they're done. We'll look at a bunch of detailed connections. I see that somebody asked about some connectors and other ones. I know, Kurt, you might have sent me an email earlier today or this week about split plate connectors. That's not something we're going to get into tonight. We're not saying that a material can't do it. It's just not something that we look at from a specification standpoint. That's going to have to go through a third-party engineer. So unfortunately, we really can't talk to that. But everything that's up on this screen is really what we're going to be touching on. And I think it's going to be a good amount of material. No, we don't have any handouts at the moment. What I can do is at the end, usually Fine Homebuilding Magazine sends out any of the information and any of the links that you'll see tonight in the presentation, and you'll get that as a separate email to move through. So moving on, let's talk about Microllam first. Microllam was the original engineered lumber back in the early 1960s. A builder and a engineer pretty much got together and looked at what Mother Nature creates. We take that material, they stripped it down and basically rebuilt with pure wood fiber, something that has none of the imperfections. So removing knots, removing any types of twists, things like that, and to be able to to create a structurally stable and a dimensional product that from 0 inches all the way out to 64 inches, which is what we usually create these billets at, we can tell you at any point or any increment within that what the design values are. That's not something that can really be done within standard 2x framing material. So why would we choose Microllam? From a structural standpoint, its modules of elasticity are pretty high compared to standard framing lumber. It's at a 2.0 E modules of elasticity, so pretty stiff. For those of you that might be on the call that are distributors, some yards are a lot smaller than others. Because of its ability to be plied together, we have certain distributors that want to take multiple SKUs of Microllam because we can go from 1.75 inches. You can put 2, 3, and 4 together to end up with a 3.5, 5.25, or 7-inch beam, as opposed to purchasing it as a solid member. It really depends on your market and what you're doing. Briefly, I discussed, why? It's specified. Truss Joist is known as being the most specified product in the markets throughout North America. And the reason for that is we were the first that were out of the gate. We owned the patents to all of the technologies that you're going to see tonight. And as other producers came into the market and those patents ran out, they were able to start creating another market to be had. Oh, I don't know why that's moving so quickly.
Steve, when you talk about the billet that it's made out of, can you speak to that manufacturing process a little bit more? I think that's something that a lot of your boots on the ground carpenters really find interesting.
Yeah, absolutely. And what I would say is if a lot of you that are interested in this, we have manufacturing facilities in the South, the Mid-Atlantic, as well as the West Coast, that if you ever wanted to get a tour to see how this is made, I urge you to talk to your territory managers to take you on a tour. But when I look at Microllam, think of Microllams as a plywood on steroids. So Microllam, or LVL, stands for Laminated Veneer Lumber, and it's an alternating veneer used in 3 different grades, an A, B, and C grade, and they're laid up with glue. They start out as a large mat. They're gone through a press and microwave heating technology that secures that glue and basically crushes that billet down into the 1.75 inch size. Now we make that typically at 64-foot lengths and widths, I think 4 to 6 feet wide. And at that point, what we'll do is they'll be cut down on a ripping bandsaw to get the different depths that come out into the market. Weyerhaeuser only makes an 1.75 inch product, and you'll see why in a little bit. The biggest thing that we're looking at from a ecological and a green standpoint, you'll see on a lot of these slides, it says technology that maximizes fiber strength. But not only that, we're trying to maximize every bit of fiber from the tree that we're harvesting. You have to remember that we're not going out and clear cutting old growth forests. We have almost 13 million acres just in the lower 48 states alone that we're harvesting on a regular basis. And out of that 13 million acres, in order to supply the industry in North America with truss joist engineered, we only harvest between 2 and 3% a year in order to do that. I'll let everybody else do the math, but that's very, very small compared to what the solid sawn section would be taking down to build the same exact size house. We're not going to really be talking about the technologies tonight of iJoist, but it's all about maximizing fiber and taking anything that we would be considered waste and using it in another opportunity. One thing that I do want to speak to is that no engineered lumber that's out on the market is a recycled product. It's all secondary growth. It all comes from harvested trees. It's not reprocessed material in any way, at least not yet. Maybe somewhere down the line that'll actually happen and we can do more recycling of houses that come down as we do renovation work. So in typical widths and everything that I'm going to talk to about tonight, because we do have we have 150 participants on right now. Like I said, I'm based out of the Philadelphia market. Anything that you see tonight, make sure that you talk with your local distributor, territory manager, or sales rep to make sure that the products that you see tonight are also available in your territory. But for Microllam, most of these are always going to be available. It just depends on the coatings that are put on them for their process. But 5.5 through 24 inch in depth, 1.75 inch wide is typically going to be available anywhere within North America. So different applications. A lot of people are like, well, where's the best use for microlams? For us, where I'm located, roof construction is a huge process for it. Rafters, you can see in these two different ones that we have long span rafters in that upper right picture. And in the lower left, this is a house that we're doing in New Jersey. It's a little hard to see, but all of those LVLs are actually cut to a radius so that it looks curved on the inside and the outside of the house. Those were all taken out of 24-inch LVL and cut down into about 11-inch rafters in order to get the 24-foot lengths. We didn't do the engineering on it. We supplied the material and helped with the takeoff, but you can see more in the background, that curve that's in the roof, really, really cool. For those of you that are on from engineering and architecture, even framers, remember that hips and valleys are always considered structural. They're going to be taking weight. So another application, 1.75 inch, are going to solve quite a few of your hip and valley areas. And the difference between ridge beam and ridge board. Beams are going to take load and need columns to support that. Ridge boards are really just a place for the tops of your rafters to come together. One of the big things is they come in deeper depths. So obviously, if you have a 2x10 rafter with a plumb cut up at the top, you're going to be longer than that 9.25 inches. So you're going to need something deeper, 2x12, or in this case, probably what we see most is 1.25 inch or 1.75 inch by 14 for a ridge board. When we talk about the difference between boards and beams, one structural, one is really there just as a stabilizing material as we move through. Floor systems is another big application, depending where you are in the US. It meets the floor joist requirement for unprotected first floors. And what I mean by that is if you have anything of a crawl space that's over 4 feet that can have storage or contains gas-fired appliances, this works with the fire requirements for the burn requirement of where a 2x10. So in this application, you wouldn't need to use, it would line up with the same burn rating as a 2x10. You wouldn't need to use sprinklers, any type of gypsum, wallboard, sheetrock, or OSB to protect the floor systems from any fire that's coming from an unprotected basement. Cantilevered assistant, I say protected here because we're talking about areas that are out of direct contact with rain or moisture or consistent moisture that's going to be over 16%. This is actually at an engineering firm in Pennsylvania, and it's a floating staircase. You can see the steel that's lined up in between. But this is actually fully exposed. They wanted the look of this material, and it's actually quite stunning once they added some stain to it and let everything move through. So that's where we get to the stair openings and headers, where the headers of stair openings, where 1.125" rim board just maybe not cut it. So as we talk about the whys, we also have to talk about the why not. And the biggest thing about the why not with microlams is going to be bracing and lateral stability. Anytime you ply material together, whether it's 2x4s and 2x6s to make a column, LVLs to make a header or a joist or some type of beam, you're relying on the connection detail of the nails or the screws or bolts to help with shear. And when we talk about lateral stability in headers especially, a connected member is never going to be as strong as the same size member that doesn't need that connection detail. And it's just the way engineering and science works, and we'll take a look at it. So here we're showing a failure, and failure is a strong word, so I don't want everybody to freak out and go run out and look at what's going on. As long as you have engineered drawings and an architect that's working on your projects, you're good. But just some of the things that we look at is we have a 2-ply LVL that's here, 16-inch, that's working as a dropped header, and we really don't have a lot of weight on it. You're looking at 6 feet of tributary of floor, 8 foot of roof on top, for maybe a total of 600 pounds per linear foot. But unfortunately, because of the way that weight's going into it and there's no braced length, we have a beam that's actually separating and bowing out over 1.125 inches. And this is quite typical in unbraced applications. And from the outside, you can see that lateral deflection as it pushes to the outside of the building. And what's causing that is, it seems counterintuitive when you look at this, and I talked with our engineering team today, you almost want to tie a rope to the bottom to help pull it back in. But the way to get around this is by literally stabilizing the top of the beam to allow you to distribute the weight correctly. And one of the ways that we can kind of look at this is through Forte Web software that somebody brought up earlier. And what I have here is 2 different applications for that. We're looking at a 3-piece microlam here on the right. Let me see if I can zoom in a little bit for you. At a 20-foot length, let's say this is a header, and right now it's failing in moment by 142%. And the reason for that is because at that 66% decrease that you have to take in the moment because of an unbraced length, and you can see that we're only bracing at the endpoints, is the reason that it's failing. If we slide over and take that exact same, which I don't know why it went to 4-ply, but it's all right, it's still gonna work. Even as a 4-ply and 16-inch, if we add top edge bracing, so right now it's saying that at 8 foot 8 inches from either end, so technically you could brace from the center if you brace in thirds. By doing that, you're reducing your moment down to only using 78% of the capacity. Now, I know that's a lot for people that don't get into the engineering jargon, but that's the difference of what an unbraced and a braced length of a multi-ply member would do. What's interesting is if we take that same information and move to a solid section member, so we've got, instead of a 3-ply, we're looking at a single member at 5 1/4 by 18, same loading, same distance. We only need end bearing points. And even at that, we're at that 78%. The reason for that is just the cohesion of the fibers allow a solid member to take more load in unbraced length. So I'm going to stop there because that was a lot of information to kind of push out and see if anybody has any questions about that.
Can you talk a little bit about acceptable methods for bracing?
So acceptable methods, if I go back one of the ways we could have solved this lateral stability, let me zoom back out. Whoop, that's way too far. Let me go back here. When we look at the unbraced length, we're talking about a 4 to 6 foot knee wall above. So that's not bracing. So basically it's a hinge point that wants to push that joist out as the weight's coming down on it. If anybody's sitting there and has a ruler, take the ruler and add weight to it or try to bend it, and it's going to want to flip out on itself. So how you could brace that is bring that all the way up and put the header on top where the floor joists are and cripple down. So put that 4 to 6 foot instead of a knee wall, cripple down into your garage door header. How you just brace that entire length would be with the floor joist. And in some instances, you can actually brace that length. Let's say it was a cathedral ceiling, depending on how it's attached and if the upper plates are there to help with bracing through an engineering standpoint, that upper plate can actually do it. The only way to solve this for this instance would probably to put horizontal or actually like diagonal kickers in the garage door opening to help stabilize. That's something that we would have to go through a third party engineer for. We don't look at how the actual bracing is being applied. We can only tell you that bracing is necessary. We can tell you that floor joist bracing is 100% needed. And if you want to learn a little bit more about it, TJ9000, if you go to the Weyerhaeuser website, wy.com, look at TJ9000, page 25 is going to have a little bit more explanation on suitable ways to prevent this from happening outside of really going with, like I said, that solid section member. My two ways of doing it is either go with a solid section like a Parallam, and we'll take a look at that next, or make sure that that header is tight up to those floor joists or up into that upper part of the cavity, and then build down to your frame for what your garage door height is going to be. So yeah, Ralph put in there that one side loading is also a factor. That's absolutely correct. When you're applying multiple plies together, the strength of the member is really reliant on the transfer of weight or the transfer of shear through the connection of the member. So unless you're working on something that's uniformly loaded from the top, this is something that is always going to have to be looked at to make sure that if nails aren't going to be the solution, are we going to need some type of structural screw to transfer the weight from the inside ply where you may be hanging material on to make sure that it's transferring all of that load and that stress to the second, third, or fourth ply out. We're actually going to kind of look at that a little bit later in the discussion. So again, we have a blog on our warehouse from our engineering site. They're going to talk about the advantages and disadvantages of solid section beams. And Chris just posted how much of a concern is that versus engineered versus conventional lumber. It's going to be the same. So conventional lumber is, again, you're going to be plying that together. You're going to want those all the way up to the top. Or have that looked at. Again, you're making multiple plies that are relying on the connection, not necessarily on the structure of the material itself, to make sure that that doesn't happen. So the gentleman, I think it was a gentleman that just put up there about what about side loaded? So we've got a side loaded 3-ply LVL here. And I think somebody talked about cost between this versus a solid member. And for years we've looked at this. So I finally kind of put some numbers to it in our local market. And if you were to put this 3-ply 16-inch together, you could use 3 rows of 10D nails through every face at 6 inches on center. You're looking at 258 nails that would need to go into this 3-ply Microllam to actually make it work at a cost of, we're talking pennies per nail, but we're at $5.75 a nail. We could also take a look at Simpson screws and say, all right, well, what if we went further? Now we've eliminated all that 6-inch on center. We've moved to 2 rows of screws at 29, or I'm sorry, at 19 inches on center, at 28 screws, but only from one face, but you're looking at a cost of approximately, let's say, $20 out in the market. What you really need to look at, if you were getting away from the connection detail, is just the labor. As labor increases and labor shortages are rampant throughout the US and into Canada, think about the time that it's going to take. You're going to need most likely two people to pick up each section, move them into place, cut them to length, lay out and do the attachment and secure all of it. Let's say they each make $25 an hour. No, I'm not saying that it's going to be an hour to do one of these, but you can see where this adds up over time, the cost of an entire house. And at the end of the day, you could be looking at a material cost of an increase of $50 or more just to make a 3-ply material, where when you kind of look at 3 plies together versus a single ply member like a PSL, at the end of the day, if you really did the math, they're probably going to come out to almost the same price. So I've got a question on here from Jeff Kelly. He said something about, do we offer flitch beam buildup? Man, I wish we did. Unfortunately, we have not gotten to that point yet. And the easy answer is wood and steel act differently. So it's very difficult to teach a computer program to do that. A lot of people still do hand calcs when it comes to flitch beams. And then Brian said, same price, but which is a better solution? It really depends on your application. And we'll get into that in the next couple of slides. So let's talk about Parallam so we can really start to put these together. In my market, Parallam is probably the #1 product that's used over its Microllam cousin. Still, it's a 2.0e modules of elasticity, but we're getting into that single member sizing. We're looking at 3.5, 5.25, and 7 right from the manufacturing standpoint. The other great part about Parallam is that we have treated Parallam Plus that's really an East Coast product. But hopefully we'll be able to expand that because this year we changed our treatment to MCA, which is micronized copper azole. And that beam is treated at a 2.E prior. So you do lose some of the stiffness, and that's going to be with any pressure treated material. Once you introduce that pressure treatment, you do change some of the cell structure, and it is going to be a little bit more pliable. Our columns are going to stay the same, so we're still going to be a CCA, so that's going to allow for direct contact or embedment, as well as saltwater splash and freshwater applications. We do take a little bit of a reduction in the E at 1.8, and the reason for that is it's not necessary to have a 2.E. When you think about the way fibers are done in structural lumber, when you have a beam, everything's running kind of in horizontal, so you have that ability to bend. When you're doing a column, think of straws. If you were to take a pack of straws, how hard it is to squash them when you're standing on top of them. And that's why you don't need the stiffness necessarily in the column. What's great about our treated material is that it's all the way through to the core. We're not going to need any extra treatment for end cuts. All of our material can be stained or painted. You'll see there's a couple of asterisks there. What I would do is refer you to, I think it's Tech Bulletin 310, and that's going to give you the pH values that we would require those stains or paints to be used with this material so that we don't have any interaction with the glues or resins that are used. The other great part is just one more thing that we add into the truss joist portfolio. Typical beam sizes, again, this is going to always relate to your market. 3.5 through 7 in the widths, and depths are going to be 9.25 through 18 on most of the East Coast. I know some of the West Coast, you'll be able to get a 2.2 E beam because that's done with Doug Fir out there. That's what their wood basket is. And they can also do a 20 and 24 inch out in that area. So always check. When we get into our treated beam, we only do 3.5 and 5.25, and we reduce that depth. We stop at a 16-inch depth beam. So always check to see what's available in your region and what's stocked locally. But it doesn't hurt to ask your territory manager if there's something for a large project that can be brought in. Typical column sizes, again, are going to work within standard wall applications, 2x4, 2x6, and even a 7x7 column where we can do 2x8. What's great is the 7x7 is also available in treated. So that's great for some large deck applications or wet location that you might be using it. For those of you that want to use shallower depths, especially in a horizontal application, columns can actually be turned on end. They're the same material. They're the same Parallam or PSL. What you just need to do is just run it through the Forte calc and make sure that it works in that horizontal application. But there's a lot of instances in shorter headers that you can get a column to work where something that's deeper necessarily isn't. The other great thing is now that shear walls in a lot of these large applications or out in areas that are using where base flood elevation and design elevations are required, you can actually drill holes through the vertical capacity of it in order to get that tie down from the foundation all the way up through your walls. So again, something to take a look at and know that it's possible when you have a single-sized member. So when we talk about treated Parallam, I've got 3 slides up here. Obviously, they're going to be high moisture content areas. They're going to be areas that are continuously getting wet. They're going to be areas that may be parts of life safety, areas that are hard to replace, or even more so, hard to inspect. So when we talk about inspection, let's take a look at this bottom one. The issue here is this was a cantilevered balcony, and it was extremely hard at 3-4 stories up to actually get out and see what was going on. And this was a failure of material because it wasn't treated. This was not our material, but this is where we talk about life safety and using it in areas that are hard to inspect. If this was done in a treated material, whether it's Parallam Plus or a treated 2x, you're not going to have areas like this that degrade and could possibly shear off. Here they were hoping that the flashing detail and that the covering on top was good enough to keep the water out. And that kind of moves us to the second slide in this area. In an exposed deck where you have nothing underneath and addition for exposure of moisture on top, we always recommend treated Parallam or treated material. Now, if you were to take this and enclose that this was a room above, so that your walls and your siding came down and actually went below the treated or the area that's needed, this beam wouldn't have to be treated. Now, if you flip that in the reverse and say that the bottom area was a room and the upper deck was done in, like, let's say poured fiberglass, anybody that's living in the downstairs, again, we're talking about inspected area. So if you had a leak in that fiberglass deck and it was dripping on your head every day, you're going to fix it. It's something that's easily inspected, easily fixed. It's the areas that we don't have some type of room, or we'll call it conditioned area, that you could actually see this going on. And then the third slide really just shows that we do have the ability to work in salt applications, not in direct saltwater contact. It can be used where there's splash, but saltwater immersion, because of the different microorganisms that live in it, the treatment isn't there. So you would have to go with a higher treatment. Typically a copper naphthate is where you'd be on that.
Do you have any information about specific fasteners that you suggest for the treated Parallam?
So all of the treated Parallam, for its corrosive ability, you're going to want to go with a hot dip galvanized, unless you're working in a highly salt atmosphere. So when you get to the shore points, That's where a lot of your stainless steel connections are going to come into play. So like with any application for any building code, always check with your local building official as to what they require for that area.
You mentioned the life safety aspect of this product. Is there any fire resistant version of it that's available, or can it be made fire retardant?
As of right now, no, it cannot be made fire retardant. The fire resistance that's going to be in there would be similar to any type of solid member in its burn rating. That's going to be something that I would have to go back and look up. I know somebody posted up there, is there any fire I-joist that's out there? And right now, no, we currently do not have a fire resistant or fire rated I-joist. So yeah, you'd really have to look at the design values and see what's allowed, like in commercial work or multi-family residential, like in 3B. I know that they want like a solid sawn Doug fir for their exterior headers, where right now engineered lumber is not accepted in that. But hopefully that's going to change over time. I mean, every day we're moving towards more applications. The other great thing about Parallam is being able to get those long spans, and especially in tall walls. Because of its structural strength and the sizes that it comes in, we can get those areas in Montana, Colorado, out on those ski slopes where you want that gorgeous view and nothing but glass. Well, something's got to hold that in place. And if you don't want to use steel and you want to be able to still work with wood, we have the ability to design that in columns and in headers. Doing longer spans just kind of pictures to pique everybody's interest as we move through. So one of the things, like I said, let's do the math. We did the math on the LVL and saying, could it be up to $50 or more depending on the application? Well, looking at a PSL column or beam for interior or exterior applications, what's great is it's a single size member. It's a one and done installation. You're really not looking at any extra labor or fastener costs. Some people are going to throw out there, oh, well, we need a crane to get it into place. You may, but if you look at any manufacturer, whether it's us or a competitor, even if you are plying the materials together from an LVL, the understanding is that those LVLs will be supported in such a fashion that they stay straight and true during the application process. So for those of you that are carrying them up your scaffolding, setting a ridge board into place and then nailing the second, third, or fourth together, I really hope that you have some type of support so that you're not inflicting self-weighted deflection and then adding your roof rafters and wondering why your roof has a fantastic Asian flair to it with that sloped roof. And yes, out in those pagodas and stuff, the history behind that, it's a sloped roof because dragons don't land on roofs where it's not a flat area. So that I learned years ago on a house from a customer that lived in Japan for years. They wanted that in North Jersey. They wanted it built like that. So just useless trivia that may save your life someday. So what I want to do now is, again, we talked about the positives, the negatives, but when you really to look at the two materials, they are similar and they do have their differences. So let's look at them from a head-to-head standpoint. Cost of material is pretty much comparable. Somebody just posted up, what's the weight per linear foot? When you get to the material, if you ply Microllam together, whether it's going to be 3.5, 5.25, or 7, the final width to weight ratio is going to be almost the same. So a 3.5 inch by 14 inch Parallam is going to weigh almost the exact same amount as a 2-ply 14 inch Microllam. So when it gets to the actual weights, those I would have to look up because it's weight per foot, and those are something that I really didn't have to commit to memory. Both are going to be a 2.0 E modules of elasticity, except for our West Coast Parallam. That's going to be a 2.2 because of the way that it's made from Doug fir. The other part is it's going to come with a fantastic Weyerhaeuser warranty. and they both work within the Forte software. So you can look at the pros and the cons of both of them and how they're going to be used in your application. Where they kind of diverge is all of our microlams are done as, or at least in Forte Web, are going to be in Moment, are going to be a 2600 F sub B. They're going to be used for interior or dry use only. So anywhere where the average moisture content is going to be less than 16%. We do make them in widths of that 5.5, 7.25, and then we can jump to that 20 and 24, which are a little bit different than what we make Parallam in. And one of the things is you're going to need continuous top edge bracing, and we saw that a little bit earlier in one of the calculations that we did, where conversely, when we look at our Parallam is made in 2 locations. It's made in Vancouver on the West Coast, and it's made in Buchanan, West Virginia here on the East Coast. And at least on the East Coast, that's going to come out with a 2900 F sub B. So we're going to be a little bit stronger. It comes in 3 widths. It's going to come in that 3.5, 5.25, and 7-inch widths. It allows for that vertical tie down, works great in tall wall applications. And we also get the ability to treat it all the way to the core for exterior use. So again, not that we're pushing one for the other. They each have their opportunities, they have their pros, and they have some cons as to where you may be using them. What I'm trying to get across today is that if you've always been using Microllam because you think it's cheaper, it would really be great to take a look in your region and say, if I add that instance of labor and all the stuff that's being done and really have to teach my guys how to lay something out. I mean, it's extremely important that we're not just willy-nilly that's a whole lot of nails, we got them in there. There is engineering behind how that nail application works. So I urge you to make sure that you're following either any of our recommendations or what our calculation packages are doing. So designing for the field, what are my options? Your options are, you can take a look in TJ 9000, which is a beam catalog, and just kind of like look through and say, oh, well, here's my weighted floor, here's my span, what do I need? We can even go to the idea of, well, let's say I'm going to use LVL or Microllam. You can go right towards a uniform load, whether it's going to be applied from an outside member for an offset load or directly over top, and say, well, this is my opportunity of saying how it's going to be applied together. But remember, these are all the very conservative, if you found the material on the street or found the information from anyone that manufactures engineered lumber and followed all of the footnotes, all of the ways that the construction is done, you could build an assembly that passes code and passes engineering design. Where we start to get really further into it, we could go into doing all of the calculations. You could see here that there's a whole lot of math that none of us probably remember from our high school days, unless you're actually in the engineering field. None of us really want to have to do this. That's why Weyerhaeuser has their Forte Web software that does all that calculation in the background and allows builders, framers, anyone to really go in and access. And as long as they plug in the information that it's asking, it's going to give you a calculation that comes out on the other side. And when we talk about that, I want to go back to that drop beam again, because we talked about holes in microlams. We've talked about holes before on the horizontal in beams, and everybody thinks that they're very restricted to what can be done. And I'm going to say to any of the plumbers, electricians, any of the guys that are or girls that are in the MEP industry, stick to that guidebook. Do not drill a hole in a beam unless you've talked with a local professional, territory manager, or somebody at Weyerhaeuser. Because what I'm going to show here is most of our material as a beam application, we are going to be conservative and say that all of your holes have to be in the center third horizontally and also in the center third coming in from the ends. The maximum hole that we typically allow in our literature is going to be 2 inches in Microllam and Parallam. But what's great about this is I was actually able to design this material. So it's 3 pieces. So we're looking at a 5 1/4, 11 7/8 Microllam that has uniform loading. And you can see here that I was able to drill dead center a 6-inch diameter hole. And as a result of that, in shear, we're only using 9% of the shear in that beam, and we're only using 76% of the moment. So I probably could go bigger, but for residential construction, unless we're dropping HVAC pipes, just about any electrical or plumbing hole is going to fit within that 6-inch opportunity. But definitely don't ever think that you're 100% tied to what the book says. Always reach out and ask for additional information. So with that, I like to go with what should I do now? I mean, there's a lot of information in the past 45 minutes that I've given, and I want to kind of condense it down and give you a little bit of something to think about. What I want you to do is lean into truss joist. That's what you need to do now. And what I mean by that is, what is truss joist? We've talked about a brand, we've talked about products, and we've also talked about tools like Forte that you can use. But we're a lot more than that. We're not just about the material and nature and selling of products. And for those of you that were paying attention in the beginning, this is where that 3 numbers come up. So if anybody in the chat wants to throw down those 3 numbers, we're going to talk about that real quick. And does somebody put in the chat or the questions, if anybody remembers at least one of those 3 numbers?
I think Richard's 3 for 3 in the Q&A.
All right, yeah, he is. So he's got the 10, 19, and 56. So congratulations, you get bragging rights for the night since you were the first one in, and you were the first one that were correct. Depending on where you are, Richard, I would reach out to your local territory manager and tell him he owes you or she owes you a t-shirt or a tumbler of some sort. So we'll start with 56. So 56 is the amount of territory managers like myself that are represented throughout the lower 48 states and Canada. So there's 56 of Steve Radowski's guys and girls that work for Weyerhaeuser and Truss Joist that can do the exact same thing that I presented tonight. Make sure you reach out to them. They're actually split up in 10 separate strategic territories. I'm located within what we call the Mid-Atlantic. New England is now considered, I want to say it's the North Atlantic, but I think that was changed. We have the Midwest, we have the Gulf South, South Atlantic, and because each area has a different building atmosphere, it's just a different way to kind of combine us together. And I think the number that's really staggering is out of 56 people that are running the same job, 19 is the average number of years that we've been in this job. I've only been doing this for 8 years with Truss Joist. I've been doing this for 48 years total in construction, and I'm only 45 years old. And for those of you that understand construction math, when you grow up in a family-owned company, you get a lot of overtime, and that's how I get 48 years at 45 years old. Some of you can actually feel and work with me on that. But what we're getting is these 3 numbers do one of the best things. It builds a brand, it builds Truss Joist, and it allows everybody that has the opportunity to be on this call today to understand that you are building with the best. When you're getting a Truss Joist and a Weyerhaeuser product, it's not 100% about the material. It's about all of the information and the vast knowledge from just 56 territory managers. And I think Andre Sujansky, who's actually the engineer for my territory, if he wants to throw up there, I want to say there's 10 internal engineers that also support the 56 of us that can work with your architects, your outsourced engineers, your builders, all of your MEP product providers to be on site and help you with building a better and more efficient home. So with that, all of those resources down here at the Specification Center, you can take a look to see who those 56 territory managers are in your locations. And feel free to reach out to us. That's what we're here for. We're here to have conversations. We're here to make your job easier and to build a better house, build a better mousetrap. And with that, I'd like to leave at least the last 10 minutes for open forum. Questions, comments, concerns, the good, the bad, and the ugly.
So one of the questions that popped up, and it's been on my mind as you were explaining the two different LVL and PSL types, is what type of woods are you guys using for these? There's got to be some kind of mindset engineering process that goes into choosing those, right?
Yeah, so it's really going to depend on the location in the US where they're coming from. If you're getting things from a mill that are down in the Gulf South, those are primarily going to come from Southern Yellow Pine fibers. Buchanan, West Virginia, our microlams are going to come from a mixture of Southern Yellow Pine and poplar, which is the softest of the hardwoods. When you're looking at our Parallam, they're also going to be a mix of those. However, when you move to a treated Parallam, that is going to be 100% Southern Yellow Pine, because Southern Yellow Pine is the only species that takes and can hold pressure treatment. When you get out to the West Coast, they have a huge basket of Doug fir. Their Parallams are going to be made from Doug fir, and that's why you see a jump in modules of elasticity to a 2.2E, because they have a much, just by its nature, Doug fir is a stiffer product compared to what we can harvest here on the East Coast and in the South. And for Tom, so on TJ 9000, that's going to be page 25 for bracing areas. So he also says peeled veneers or sawn flat. So all of our veneers are peeled. The easiest way to explain that is grab a roll of paper towels, or let your kids do it. Stick your finger in the end of paper towels and let them run through the house. That's basically how veneers are cut out of logs. When they come into the mill, they're dropped into a lathe, they're pinned at either point, everything's kind of balanced, and then a knife gets dropped into that spinning lumber. And basically it's going to peel all of the veneer out of it until it hits the pith. And the pith is going to be the center and the least structural part of a tree. And that's going to actually get kicked out and be used for other opportunities, such as fence posts, maybe dunnage, things like that. So we're using all of that new fiber that's on the tree, and then they're going to be graded out as an A, B, and a C. Your A, Bs, and Cs are what make up your microlam billet. Anything that doesn't necessarily make the cut, I hate to say waste, but that's one of the reasons we created Parallam. Veneers that don't make the cut or maybe are damaged, they can be cut down into smaller strands, and then those strands are going to be compacted into what we see as a Parallam. And that's why when you look at the end or the section of a Parallam, it almost looks like it's worms all crushed together, because it's not full veneers, it's strands of veneers that are actually adhered in one direction.
You've had a couple of questions about the Forte software. Can you go through how somebody would find that online, and then just the general inputs you have to have at the ready?
Yeah, so it's pretty straightforward. So if you go to forte.com, it's an online-based software. We also have a mobile phone application, or an iTablet if you're on, or a tablet if you're on site. Basically, it just has you registered, so that gives you access to being able to use the software, and so that you can have live chat with any of our engineers or product support specialists to work through it. So really, the only thing you need to know is some simple terminology. Typically, we work with clear span, so that's going to be either for beams, I-joists, or rafters. And when I talk about clear span, that's going to be the distance between the supporting members. So it's basically if you were to touch the inside of your walls, that's the clear span. The wall itself or anything going to the exterior would be what we consider the out to out span or the overall span. We're more concerned with that interior span or that clear span. From there, the only thing else you need to know is going to be what we call tributary width. Tributary width is going to be half the dimension of the overall span. So if you were running a beam and you had joists from one side coming in and joists coming from the other to meet that beam in the center, 50% of that load is going to the beam and the other 50% of the load is going to the exterior walls. So your tributary width is going to be the distance of your floor joist, half of that. So half of the weight you want going to the beam without having that actually, because I wasn't actually looking at speaking about Forte tonight. With the time that we have, I really can't bring it up to show anybody, but we can talk about it at a later date. From there, it's just adding live and dead load and snow load. So typical loading for residential construction is going to be 10 pounds of live load, 10 pounds of dead load and 40 pounds of live load for living areas, and 10 pounds of dead load and 40 pounds of live load, 30 pounds of live load for bedrooms. And that's going to be your bare minimum. From there, you can always extend what your loading is. If you're putting large format tile, are you adding concrete overlay? Do you have point loads that are coming down? It allows you to kind of build all of that together. And in the job tree, it also allows you to stack loads and link things together. Anybody that's really interested in Forte Web, I urge you, when you get your follow-up email, and I'll send that information out to Fine Homebuilding, reach out to your local territory managers and ask more about it. Once a month, they have Forte Live. So there'll be a live presenter talking about the tips and tricks to use it, especially if you want to become more proficient. But just going in, there's a live question and answer area where you can talk to somebody within 1 or 2 minutes of asking a question. And there's a lot of resources in the Weyerhaeuser Learning site that can teach you. I think I've got a 4-hour video that I did with one of our engineers during COVID that actually walks you through setting up your account all the way through residential construction and then moving into commercial construction, things like banks and office buildings where you have to have what we call safe loads. And I don't mean that from a safety standpoint. I mean that from an actual roll around safe that could weigh 1,000 pounds that could be moved around within that floor system. It has the ability to do that as well. So I appreciate everybody's questions and interest in that software. It's updated quite often, and that's the reason that it's an online product so that we can always be rolling out. The other great part about it is, depending on where you live in the country, you can actually put your zip code in, and it's going to change colors for materials that are local to your market so that you're not trying to specify something necessarily that you can't get your hands on right away. So the last one that's on there as we wrap up in the last couple of minutes, Daniel has, how small of an opening needs lateral bracing for an LVL header? That's really going to depend. If you have an extremely heavy point load that's coming down on top of it, you may not get the lateral stability out of what you're using. Again, showing that lateral stability wasn't there to scare people into using a product. It was just knowledge to let them know that this is something that needs to be looked at. My favorite quote from builders or from people that call in is, well, why does the beam have to be that big? There's no weight on it. And then when you start talking to them, you're like, well, no, there is a lot of weight on that. You've got a post coming from the ridge. You've got offset bearings from a balcony that are coming, or a floor system coming from the left, something else that's coming from the right. It's not your old style simple house. I live in a Bucks County farmhouse. My house is 17 feet wide at its widest point. Um, and I'm working on floor joists that are oak, that are 4 inches wide and 7 inches deep. And yes, you are not playing competition marbles. They will all roll to the center. And when you walk through the house, it sounds like a herd of elephants.
Well, I think, Steve, as we wrap up here, that's been a lot of great information, and I hope maybe you'll come back and you'll do one just on Forte. There was a lot of interest in that program, and it's one that I used extensively in building my house, and I think it's very useful out there for even people in the field or small scale residential designers.
Yeah, absolutely. Whenever I know, I think we've got a second one scheduled for later in the year. I know that's usually more of a round table, but if Forte is really something that everybody wants to know more about, definitely, if you're not reaching out to your territory managers, we can provide that type of opportunity.
Yeah, a lot of chats and a lot of talk in the Q&A here about Forte, so I think that'd be a good one to bring back here. But as we sign off here, I want to thank Steve for joining me, and thank you for the I think at the high point I saw we had 177 participants, so that's a really great turnout. And again, just want to thank Steve for his time and thank everybody for showing up this evening.
Thank you, everybody. I enjoy it. Thank you, Ian, for hosting, and we'll see you on the next one. Be safe, everybody.